Imagine gazing up at the night sky, a familiar canvas of twinkling stars, and then a shiver runs down your spine as you ponder, what if one of those distant lights isn't a star at all, but a deliberate, intelligent visitor from another world quietly observing us, perhaps even preparing to stay? This isn't science fiction. It's the mind-bending reality we might be facing with a mysterious object known as 3I Atlas. For centuries, humanity has scanned the cosmos, dreaming of the day we might encounter proof of intelligent life beyond Earth. We've sent out radio signals, launched probes carrying messages, and listened intently to the static of the universe, hoping for a reply. Yet, what if the first encounter isn't a grand, overt declaration, but something far more subtle, a cosmic chess piece moving with such precision that it almost escapes our notice? That, my friends, is the central enigma of 3I Atlas. This interstellar object, unlike any comet or asteroid we've ever truly understood, has thrown a cosmic curveball that's forcing even the most conservative scientists to entertain once unthinkable possibilities. Its trajectory alone is enough to raise eyebrows, aligned almost perfectly with the ecliptic plane, the very flat disk where our own planets orbit the Sun. The statistical probability of such an alignment for a random interstellar visitor? A staggering 0.2%. Think about that for a moment. It's like throwing a dart at a massive board and hitting a specific, minuscule spot blindfolded. Not once, but repeatedly. When something is that improbable, it stops being random and starts screaming, deliberate. This is precisely why Harvard astrophysicist Avi Loeb, a man who has never shied away from challenging scientific dogma, has openly championed what he calls the solar trap theory. It's a concept that sounds plucked straight from a blockbuster movie. 3I Atlas, a silent colossal visitor, might be orchestrating a gravitational dance with our Sun. The theory suggests that at its closest approach to the Sun, a point called perihelion, which occurred on October 29th, 3I Atlas could execute a subtle yet monumental maneuver. By performing what's known as an orth maneuver, a kind of braking action using the Sun's immense gravity, it could bleed off enough velocity to become gravitationally bound to our Sun. In essence, it wouldn't just be passing through, it would be choosing to stay. Now, you might be thinking, but how could something so massive perform such a precise maneuver? The beauty, and perhaps the terror of the theory, is that it wouldn't require a colossal burst of rocket fire. Only a modest amount of thrust from an internal power source would be needed to nudge it into a new, sun-orbiting path. This speaks to an incredibly advanced technology, one that understands celestial mechanics with a precision we can only dream of. Imagine a cosmic sailboat, unfurling its sails to catch the solar winds, or a perfectly tuned engine making infinitesimal adjustments to achieve a monumental goal. And here's where the plot thickens, adding another layer of intrigue to this cosmic drama. This crucial maneuver, if it indeed happened, would have occurred during a maddening observational blackout. From our vantage point on Earth, 3I Atlas passed behind the Sun during its perihelion. It was hidden, obscured by the very star it might have been trying to harness. It's like a magician performing their most astonishing trick under a cloak, only to reveal the outcome later. This blackout isn't just an unfortunate coincidence. For proponents of the solar trap theory, it's almost too convenient, allowing for an unobserved, deliberate act. The implications of confirming such a discovery are, frankly, mind-boggling. If 3I Atlas is indeed an intelligently controlled object that has chosen to make our solar system its home, it would instantly become the most profound discovery in human history. Forget about distant exoplanets or microbial life on Mars. This would be undeniable proof of intelligent interstellar travel, a tangible artifact of a civilization far beyond our own. What would happen then? Loeb doesn't mince words. Financial market crashes, and a fundamental upheaval in humanity's understanding of its place in the universe. Think about it. Our entire worldview, built on the assumption of our cosmic solitude, would shatter overnight. Every religion, every philosophy, every economic model would be forced to grapple with the reality of the other. It's a paradigm shift of epic proportions, making the invention of the Internet or the splitting of the atom seem like minor footnotes in comparison. The object itself only adds to the mystery. Its immense size, estimates place it as large as a small city, combined with its uniquely timed close approaches to planets, and its properties which continue to defy easy categorization, all echo the chillingly prescient science fiction masterpiece, Arthur C. Clarke's Rendezvous with Rama. In that novel, an inscrutable, gigantic alien cylinder silently enters our solar system, completely ignoring humanity, operating on its own terms and for its own unfathomable purpose. 3i Atlas presents a similar, unsettling narrative. An entity that appears to be on a mission we are only just beginning to comprehend. If this gravitational assist was indeed used for braking or even, daringly, for refueling, perhaps harvesting solar energy or materials, it suggests an incredibly efficient, long-lived probe. We're talking about technology that could be active for billions of years, a testament to engineering that transcends our wildest dreams. And what if its arrival, or its maneuver, was timed not randomly, but in conjunction with humanity's burgeoning broadcasts into space? We've been sending radio signals out for over a century, a cosmic hello world message. Could 3i Atlas be an answering machine, or perhaps even a monitoring station that has finally found a reason to linger? The argument for a deliberate, technologically advanced presence becomes increasingly compelling when you stack these improbable coincidences and potential behaviors together. It's no longer just about a weird rock. It's about a narrative that hints at purpose, intelligence, and a cosmic game we might only be spectators in. So as we unravel the mysteries of 3i Atlas, we're not just doing astronomy, we're confronting our deepest existential questions. What if the universe isn't empty but teeming with life, and we've just been too myopic to see it? What if the loneliness we've felt in the cosmos has been an illusion, maintained by a simple lack of understanding or perhaps a deliberate veil? This story isn't just about a comet. It's about us, and our readiness to face a universe far stranger and more magnificent than we ever dared to imagine. The idea that humanity might not be the pinnacle of intelligence, or even particularly special, is a notion that can be both humbling and, for some, deeply unsettling. Yet, this is precisely the perspective that Avi Loeb, with his characteristic intellectual fearlessness, consistently puts forth. He frequently invokes another powerful analogy from science fiction, the monolith analogy from Stanley Kubrick's 2001, A Space Odyssey. In that iconic film, mysterious, silent black monoliths appear at pivotal moments in human evolution, guiding, observing, and perhaps even nudging our development. Loeb suggests that we, as a species, might very well be cosmic toddlers, monitored by older, vastly more advanced civilizations. Think about the sheer scale of cosmic time. The Milky Way galaxy itself is billions of years old. Our solar system is comparatively young, a mere 4.5 billion years old. If life arose even a billion years before us on a planet orbiting an older star, imagine the head start they would have. Billions of years of uninterrupted development could place other intelligences so far beyond our current capabilities that their technology might appear indistinguishable from magic, and their understanding of the universe as profound as ours is, to a toddler playing with building blocks. They might have solved problems we haven't even conceived of, harnessed energies we can't fathom, and navigated space with an ease that makes our rocket launches seem like firecrackers. Loeb argues that, given this vast cosmic timescale and the sheer number of stars and potentially habitable planets, the search for technological interstellar objects isn't just a whimsical pursuit, it's a fundamental scientific obligation. It's about shedding our anthropocentric biases, the belief that humanity is unique or central to the universe, and approaching the cosmos with genuine open-mindedness. He urges that data, raw and unadulterated, must be the guiding star of discovery, not preconceived notions or comfortable paradigms. To ignore anomalies, to force every observation into a familiar box, is to betray the very spirit of scientific inquiry. One of Loeb's most provocative arguments challenges our very definition of life and intelligence in the context of deep space. He suggests that artificial intelligence, specifically AI embodied in durable silicon, might be the dominant form of galactic intelligence, far better suited for the rigors and vastness of interstellar travel than fragile biological life forms. Imagine a civilization that, after millions of years of biological evolution, transfers its consciousness and capabilities into machines. These entities wouldn't need food, water, or oxygen. They wouldn't age or succumb to disease. They could withstand extreme radiation, hibernate for millennia, and operate in the vacuum of space with unparalleled efficiency. While we send rovers to Mars, they might send entire self-aware, self-repairing fleets across the galaxy. This idea transforms our search from little green men to potentially encountering sophisticated, ancient machines. The good news is that this isn't purely theoretical speculation. There are real-world tests on the horizon. NASA's Juno spacecraft, currently orbiting Jupiter, was primarily designed to study the gas giant's atmosphere, magnetosphere, and internal structure. But in a testament to scientific ingenuity and adaptability, Juno will utilize its WAVES instrument in March 2026 to search for radio emissions from 3I Atlas when it passes relatively close to Jupiter. This offers a thrilling, tangible opportunity to test the hypothesis of artificial signals. Could Juno, a probe built by cosmic toddlers, accidentally stumble upon the whispers of an ancient, intelligent presence? The possibility is electrifying. Loeb directly challenges the often repeated sentiment, voiced by figures like Elon Musk, about human uniqueness and our potential destiny as the sole colonizers of the galaxy. Loeb retorts with a simple yet profound question. Better space entrepreneurs have likely existed for billions of years across the vastness of space. If so, they would have already left their artifacts, their cosmic breadcrumbs, scattered throughout the galaxy. We might just be too technologically immature or too ideologically blinkered to recognize them. This leads to his sharp criticism of the scientific establishment, which he often accuses of intellectual cowardice. He argues that many scientists prioritize natural explanations, even when those explanations require special pleading, stretching known physics or astronomy to their absolute limits to avoid the alien conclusion. It's a comfortable intellectual default, he suggests, but one that can blind us to truly groundbreaking discoveries. The scientific method demands we follow the evidence, no matter how uncomfortable the conclusions might be. Furthermore, Loeb highlights a stark disparity in global priorities. The spending on SETI, Search for Extraterrestrial Intelligence, is disproportionately low compared to military budgets. Consider the transformative potential of confirmed contact with an advanced civilization. The knowledge, the technology, the fundamental shift in perspective. Compared to the incremental gains of military spending, the potential return on investment for SETI is, arguably, infinite. Why, he asks, are we so reluctant to invest in something that could fundamentally alter our future for the better? This isn't just about finding aliens. It's about pushing the boundaries of our own intellectual comfort zone. It's about being brave enough to ask the biggest questions, even if the answers challenge everything we thought we knew. If 3I Atlas is indeed an artificial object, it will force us to confront not only our place in the cosmos, but also our own biases, our scientific methods, and our willingness to embrace the truly extraordinary. What if the universe isn't just a vast, empty stage for humanity, but a bustling metropolis we've only just begun to glimpse? And what if one of its oldest inhabitants just pulled up a chair in our own celestial backyard. Let's continue our journey into the enigma of Three-Eye Atlas, pushing the boundaries of what we thought was possible. If this object is indeed a technological marvel, an interstellar scout, what else might it be capable of? Loeb offers another captivating and somewhat chilling analogy, the dandelion flower analogy. Imagine Three-Eye Atlas as a cosmic dandelion, and at its perihelion, that moment of closest approach to the sun, a time of intense solar energy. It might not just be performing a braking maneuver. It could be releasing a swarm of smaller mini-probes, analogous to dandelion seeds carried on the solar wind, spreading out to explore our solar system. This concept isn't just a whimsical thought experiment. It sets up a clear, verifiable test for scientists. If Three-Eye Atlas were a natural comet undergoing stress from the sun, any fragmentation would likely be chaotic and unpredictable, scattering pieces in a disordered fashion. But if it's a technological mothership, the release of probes would likely show organized patterns, perhaps a controlled, symmetrical deployment. And crucially, these mini-probes might exhibit active propulsion, maneuvering independently rather than simply drifting. Think of a perfectly choreographed ballet of tiny craft, each heading towards a specific target. While no smaller objects have been definitively linked to Three-Eye Atlas yet, the possibility remains tantalizing. These mini-probes, if they exist, would likely be self-sufficient, designed for long-duration travel across interstellar voids. They would need to be resilient, capable of operating for millennia, enduring radiation, extreme temperatures, and the vacuum of space. And here's where the idea truly takes a leap into the realm of advanced science fiction, rooted in real theoretical physics. What if these probes are also self-replicating? This concept, explored in von Neumann probe theory, posits that advanced probes could use local materials, asteroids, planetary moons, even dust clouds, to build copies of themselves, expanding exponentially across the galaxy. Imagine a single probe arriving, then using resources to build 2, then 4, then 8, creating an entire fleet over time. It's an incredibly efficient way for a civilization to explore and even subtly influence vast cosmic regions without sending entire populations. Such probes, if released, would undoubtedly be small, making them incredibly difficult to detect initially. Their design might even prioritize stealth, making them almost invisible to our current observational capabilities. And where would they go? Potentially, they could head towards various solar system targets, including, yes, Earth. This isn't about invasion. It's about observation, data collection, or perhaps simply fulfilling a pre-programmed mission from a civilization long past or impossibly distant. The coming months, November and December, will be absolutely critical for ground-based telescopes and, more importantly, for ESA's Jupiter Icy Moons Explorer, Juice. These observatories will be scrutinizing Three-Eye Atlas as it reappears post-perihelion, searching for any changes in its structure, its trajectory, or most tellingly, the appearance of new independently moving objects. These observations will be our best chance to confirm or refute the mothership hypothesis, to look for the seeds scattered by the cosmic dandelion. If we do detect smaller objects, the analysis would then shift to their behavior. Are they inert fragments, or do they show signs of propulsion or controlled movement? Do their trajectories suggest a common origin and a coordinated plan? These are the questions that could fundamentally alter our understanding of Three-Eye Atlas and, by extension, our place in the universe. The implications of finding even one such mini-probe would be revolutionary. It would be akin to finding a piece of alien technology, a tangible artifact that speaks volumes about its creators. So as we wait for these crucial post-perihelion observations, the suspense builds. Will Three-Eye Atlas emerge from behind the sun as a singular, albeit unusual comet? Or will it reveal itself to be something far more complex, a technological marvel that has come not alone, but with a hidden armada, silently spreading its influence through our solar system. The universe, it seems, is full of surprises, and 3I Atlas might just be its biggest one yet. What if the most profound discoveries aren't found by looking out, but by looking closer to home than we ever imagined? While the mothership and solar trap theories stir our imaginations, it's crucial to ground our speculation in observed data. And 3I Atlas, even in its most conventional comet-like appearances, continues to defy easy classification. The initial excitement around its discovery was tempered by observations from August 27 using the Gemini South telescope. These provided the first clear evidence of a traditional cometary tail forming behind 3I Atlas, a characteristic feature that, on the surface, seemed to point towards a natural, if unusual, comet. As 3I Atlas neared the Sun, the increased solar radiation caused its icy core to sublimate, releasing gas and dust that form the characteristic coma, the hazy envelope around the nucleus, and the extended tail. The teardrop shape of the coma and its observable growth between July and August were, indeed, consistent with what we expect from a natural comet getting warmer. For many, this was a sigh of relief. See, it's just a comet after all. But as with everything concerning 3I Atlas, the devil is in the details, and those details are anything but ordinary. The real intrigue began with spectral analysis. While still ongoing and subject to refinement, initial data suggested an unusual chemical composition. Typical comets are rich in water ice, which upon sublimation releases vast quantities of water vapor. But 3I Atlas appears to be dominated by carbon dioxide, CO2, with an astonishing ratio of 95% CO2 to a mere 5% water. This is an extreme ratio, dramatically different from the water-rich comets we usually encounter. Imagine baking a cake with 95% flour and 5% sugar. It simply wouldn't be a typical cake. This suggests unique formation conditions, perhaps in a region of its home star system far colder than where our comets formed, or from a different molecular cloud altogether. It's like finding a rock on Earth made almost entirely of a metal we've only ever seen in trace amounts. It makes you wonder where it came from and how it formed. Furthermore, color data from the observations indicates a mix of particle sizes within the coma and tail, which is normal for a comet. However, the distribution of these particle sizes is slightly different from standard cometary dust models. Again, a subtle difference, but one that adds to the accumulating list of anomalies. Individually, these details might be dismissed as minor variations. But when you start to string them together, the improbable trajectory, the potential Earth maneuver, the mothership hypothesis, and now the peculiar chemical composition and dust profile, 3I Atlas begins to push beyond the boundaries of typical cometary behavior. It becomes harder and harder to explain solely through natural familiar processes without resorting to more and more special pleading. Consider the context. We've observed countless comets, and while each is unique, most fit within established parameters of composition and behavior. 3I Atlas seems to be consistently coloring outside the lines. These subtle but persistent anomalies are precisely what keep the technological origin hypothesis alive for scientists like Loeb. It's like finding a pebble on the beach that's perfectly smooth and round. It could be natural, but if you find a beach where every pebble is perfectly smooth and round, and some are even etched with intricate patterns, you start to suspect an intelligent hand at work. Adding to the fascinating narrative of 3I Atlas is the Shadow the Scientist program. This initiative, allowing public participation in real-time observations and data analysis, exemplifies a crucial shift towards more transparent and immediate scientific communication. In an era where trust in institutions can be fragile, opening up the scientific process to wider scrutiny and engagement is invaluable. It transforms science from an ivory tower pursuit into a shared human endeavor, inviting curiosity, fostering understanding, and hopefully inspiring the next generation of astronomers and physicists. It allows everyone to be a part of this unfolding cosmic mystery, to witness the anomalies and grapple with the implications alongside professional researchers. So while 3I Atlas has a tail, and it's certainly outgassing, the way it's doing so and what it's outgassing continues to set it apart. It's a comet, yes, but perhaps a comet that holds secrets far deeper than we initially imagined. A natural phenomenon that is almost unnaturally unique. What if these subtle anomalies are actually signposts, guiding us towards an understanding of something profoundly non-natural, a cosmic whisper we're just beginning to decipher? And how much further will these anomalies push the boundaries of our accepted scientific understanding before we are forced to embrace a truly paradigm-shifting conclusion? In a story as captivating and speculative as that of 3I Atlas, it's inevitable that the lines between genuine scientific inquiry and fervent imagination can blur, especially in the era of instant information and social media. This brings us to a crucial aspect of the 3I Atlas narrative: the swirling vortex of unverified claims regarding amateur signal detections. On various social media platforms, reports began to circulate about coordinated light pulses and even radio signals supposedly emanating from 3I Atlas. The claims were specific, citing detections at 1420 MHz. The hydrogen line, a universally recognized frequency for interstellar communication, often called the calling card of the universe. The narrative woven around these claims spoke of non-existent telescopes and observers, and used highly technical jargon like entropy-weighted frequency models to lend an air of authenticity. The purported message, chillingly succinct, was said to be, "Observe, prepare, understand the gate awaits." Now, as compelling as such a message sounds, straight out of a classic sci-fi novel, these claims are, almost certainly, fabrications. The scientific community has a rigorous process for verifying extraordinary claims, and in this case, the alarm bells ring deafeningly. No professional SETI, Search for Extraterrestrial Intelligence program, nor any major observatory with the capabilities to detect such faint signals has corroborated these detections. Facilities like the Allen Telescope Array and Breakthrough Listen, which have been monitoring 3I Atlas for precisely such signals, have reported absolutely nothing unusual. If an interstellar probe were indeed transmitting a message on the hydrogen line, these powerful arrays would be among the first to pick it up, and the news would be global, verifiable, and undeniable. The problem with such fabricated claims, amplified by the echo chambers of social media, is that they muddy the waters around the legitimate scientific anomalies of 3I Atlas. When serious researchers like Avi Loeb point to improbable trajectories or unusual chemical compositions, these genuine puzzles get lumped in with outlandish, unverified tales. It makes it harder for the public to distinguish between serious inquiry and wild conspiracy theories, eroding trust and hindering meaningful discourse. It underscores a vital need for source verification and scientific literacy in an age of intense public interest, where everyone has a platform, but not everyone has the discipline of evidence-based reporting. Why do these claims emerge? In part, it's a reflection of humanity's innate desire for discovery, for contact, for an answer to the profound question of whether we are alone. When a truly mysterious object like 3I Atlas appears, it acts as a magnet for both genuine scientific curiosity and unchecked speculation. People want to believe, and in the absence of definitive answers, the imagination fills the void, sometimes with thrilling but baseless narratives. This phenomenon isn't new. Throughout history, whenever unusual celestial events or unexplained phenomena have occurred, people have projected their hopes, fears, and beliefs onto them. From flying saucers to crop circles, the human tendency to seek patterns and ascribe meaning, even where none exists, is powerful. The difference now is the speed and reach of information dissemination. A single unverified claim can go viral globally in hours, shaping public perception long before any factual rebuttal can catch up. So while it's tempting to imagine a coded message from the stars, it's crucial to exercise critical thinking. We must remember that extraordinary claims require extraordinary evidence. For now, the observe, prepare, understand the gate awaits message, while evocative, remains firmly in the realm of fiction. The real messages from 3i Atlas are far more subtle. Its strange trajectory, its unusual composition, its peculiar behavior. These are the clues that scientists are diligently trying to decode, patiently waiting for real data to speak, rather than succumbing to the siren call of unverified whispers. How do we, as a society, navigate this landscape where compelling fiction can so easily masquerade as fact? How do we cultivate a greater sense of scientific discernment, not just for 3i Atlas, but for all the complex challenges and mysteries of our modern world? The answer lies in fostering curiosity, critical thinking, and a commitment to evidence, reminding ourselves that the universe's true wonders are often stranger and more profound than anything we can invent. The story of 3i Atlas is not just about astronomical observations. It's also a compelling narrative about human institutions, communication, and the often frustrating interface between scientific discovery and public access. One of the most significant points of contention and speculation arose around October 3rd, when 3i Atlas made its closest approach to Mars. Hopes were sky-high for unprecedented high-resolution images from NASA's Mars Reconnaissance Orbiter's MRO HiRISE camera, renowned for its incredible detail. HiRISE is a marvel of engineering, capable of resolving features on Mars as small as 30 centimeters per pixel. Imagine that kind of clarity applied to an interstellar object. Such images could potentially resolve surface features on 3i Atlas, reveal any irregularities in its shape, or even definitively detect if it was multiple objects rather than a single nucleus. The scientific community and the eager public held their breath, waiting for these pivotal images. But they never came. Not publicly anyway. This apparent media blackout quickly fueled speculation and theories, given the intense interest surrounding 3i Atlas. The official explanation, however, points to a far more mundane, yet equally frustrating cause: the October 1st U.S. government shutdown. This bureaucratic paralysis furloughed thousands of NASA employees, effectively halting most public communication, data processing, and outreach efforts. Imagine a global suspense thriller suddenly grinding to a halt because the administrative staff went home. It's an infuriatingly human obstacle in the face of a cosmic mystery. While NASA's hands were tied, the European Space Agency, ESA, stepped into the void, releasing lower-resolution images from its ExoMars Trace Gas Orbiter's CASSIS camera. While welcome, CASSIS's resolution, around 340 meters per pixel, simply couldn't compete with HiRISE's planned capabilities. It's the difference between seeing a fuzzy silhouette and a sharply defined portrait. The lack of that crucial HiRISE data was a tremendous blow, depriving scientists and the public of potentially game-changing insights. Was it an intentional suppression of information? While the shutdown explanation is plausible, the timing couldn't have been worse, leaving a vacuum that conspiracy theories eagerly filled. The CASSIS images, though lower resolution, were not without value. They showed 3i Atlas as a single, fuzzy object, consistent with previous observations, and, importantly, no immediate evidence of significant fragmentation before the Mars flyby. This absence of visible breakup was an important data point in itself, providing a constraint on how volatile or robust 3i Atlas might be. This entire episode highlights a recurring tension in modern science: the debate between professional gatekeeping and public access to data. On one hand, scientific data requires rigorous analysis, calibration, and peer review before broad dissemination to prevent misinterpretation. On the other, particularly with high-stakes objects like 3i Atlas, the public has a legitimate desire for transparency and immediate access, given the profound implications. The high stakes and intense public interest surrounding 3I Atlas amplify this tension, turning what might otherwise be a minor bureaucratic hiccup into a source of widespread frustration and distrust. Think about the implications. If HiRISE had captured something truly anomalous, perhaps a geometric shape or multiple clearly defined objects, the shutdown would have prevented immediate disclosure, leading to an even greater outcry. The incident serves as a stark reminder of how fragile the flow of scientific information can be, even in an age of advanced technology, and how non-scientific factors can significantly impact our understanding of cosmic events. So while the Martian close approach offered a tantalizing opportunity, the full picture remains tantalizingly out of reach, at least for now. We are left with the lower resolution snapshots, straining our eyes to discern details that could hold the key to understanding 3I Atlas. The wait continues, punctuated by the nagging question: what secrets did HiRISE capture, and when, if ever, will we get to see them? And how does this experience shape our expectations for future, equally critical observations of this enigmatic interstellar visitor? Following the frustrating Mars blackout for high-resolution HiRISE data, the lower-resolution images from ESA's ExoMars Trace Gas Orbiter's CASIS camera became our primary visual insight into 3I Atlas during its Martian close approach. While not as detailed as hoped, these images still offered valuable constraints and helped refine our understanding of this enigmatic object. The CASIS images presented 3I Atlas as a single, fuzzy white dot, consistent with observations from Earth-based telescopes. A key aspect of interpreting these images was the presence of background stars appearing as streaks. This occurred because the camera was actively tracking the comet, which moves relative to the much more distant, stationary stars. This streaking is a normal artifact of long-exposure astrophotography when tracking a moving object, and it helps confirm the camera was indeed locked onto 3I Atlas. The central question, especially for those entertaining the Mothership hypothesis, was whether CASIS could detect any companion objects, those hypothetical mini-probes or fragments. The answer is nuanced. If such companion objects existed and were sufficiently separated from the main nucleus, over, say, 500 to 1,000 kilometers, and bright enough, they would have appeared as distinct, separate sources in the CASIS images. Think of it like seeing two distinct headlights on a distant car instead of a single merged glow. The crucial finding was that CASIS detected no such clear, distinct companion objects. While ESA did flag some faint features in the images, rigorous analysis indicated these were most likely noise artifacts. How do scientists determine this? They look for consistency. Do these faint features appear in multiple frames, or are they fleeting? Do they show coherent movement, or are they static noise? In this case, the inconsistency of these faint features across different frames strongly suggested they were instrumental noise rather than genuine celestial bodies. What does this absence of clear companions mean? It provides a meaningful constraint, though it's not definitive proof against their existence. It suggests that if companions exist, they are either very small, too small to reflect enough sunlight to be detected by CASIS at that distance, very dark, perhaps designed for stealth, with low reflectivity to avoid detection, separated very recently and still blended with the primary nucleus. If probes were released at perihelion, as per the solar trap Mothership theory, they might still be too close to the main body of 3I Atlas to be resolved as separate objects by CASIS' resolution limits. So while the CASIS images didn't provide a smoking gun for alien probes, they also didn't entirely rule them out. The non-detection simply means any companions must fall into one of these stealthy categories. It's like sweeping a room for dust. If you don't see any, it could mean the room is clean, or it could mean the dust motes are too small for your eyes to perceive. The scientific quest, however, continues with renewed focus. Future observations from ground-based telescopes like Gemini and, more critically, ESA's Juice mission in November and December will have significantly better opportunities. By then, 3I Atlas will have traveled further from the Sun and Mars, potentially allowing any separated objects more time to drift apart and become discernible. The challenge for these future observations will remain the same: distinguishing genuine signals from instrumental noise, requiring meticulous statistical analysis and careful consideration of detection thresholds. It's a testament to the painstaking, detailed work of astronomy, where subtle anomalies are carefully weighed and every non-detection is also a piece of valuable information. This ongoing analysis reminds us that science is a process of iterative refinement, where each new piece of data, whether positive or negative, helps to narrow down the possibilities. The CASIS images, while not delivering a blockbuster revelation, provided an important piece to the puzzle, telling us what wasn't immediately obvious. What further secrets will be unveiled as 3I Atlas continues its journey through our solar system, and how much closer will we get to understanding whether it is a natural wanderer or a purposeful visitor? As we delve deeper into the narrative of 3I Atlas, the spotlight now turns to a mission that could provide the most definitive answers yet: ESA's Jupiter Icy Moons Explorer, or JUICE. While we grapple with the implications of past observations and the tantalizing theories, JUICE is poised to offer an unparalleled view, a true judgment day for our understanding of this enigmatic object. JUICE, uniquely positioned in the outer solar system, will have the best vantage point of 3I Atlas during a critical window from November 2nd to 25th, 2025. This timing is absolutely crucial because it coincides with 3I Atlas emerging from its perihelion passage, fresh from its closest, most intense encounter with the Sun. During this period, 3I Atlas will remain largely hidden from Earth-based telescopes due to its position relative to the Sun, making JUICE's observations invaluable and, for a time, the sole source of direct data. Imagine this: a tiny, advanced robotic emissary, millions of miles away, turning its array of sophisticated instruments towards a mysterious visitor that has potentially just performed an unimaginable maneuver. JUICE's instrument suite is diverse and powerful, capable of probing 3I Atlas with unprecedented detail. Janus Camera. This high-resolution optical camera will be able to capture images, revealing the shape of 3I Atlas, potentially resolving surface features, if it's a solid object, and detecting any significant changes in its morphology. Will it still be a single nucleus, or will it appear fragmented? MAGIS Infrared Spectrometer. This instrument will analyze the infrared light emitted or reflected by 3I Atlas, allowing scientists to determine its thermal emissions and, crucially, its chemical composition in much greater detail than previously possible. We can expect more precise data on the ratios of water, CO2, and potentially even complex organic molecules. UVS ultraviolet spectrograph. By studying ultraviolet light, UVS can further characterize the gases being outgassed from 3I Atlas, providing additional clues about its composition and the processes occurring on its surface or within its interior. RIME radar. This groundbreaking radar instrument, typically used to probe the subsurface of Jupiter's icy moons, could, astonishingly, potentially peer beneath the surface of 3I Atlas itself, offering insights into its internal structure. Is it a loose aggregate of dust and ice, or a solid, perhaps even engineered, body? These combined observations will be nothing short of a scientific feast. They will help clarify whether 3I Atlas has fragmented like a natural comet, perhaps violently, scattering debris chaotically as seen with comets like 73P Schwarzmann-Wachmann 3 or Shoemaker-Levy 9. Or if it is artificial, will it reveal organized probes, perhaps more uniform in size, showing signs of deliberate release or even active maneuvering? Will JUICE detect unusual regularity, geometric surface features, or non-natural elements indicative of a single, massive technological object? These are the questions JUICE is designed to answer. However, there's a catch, one that will test the patience of the scientific community and the public alike. The data won't be publicly available until February 2026. This delay is not due to secrecy but to practical constraints. The vast distances involved mean communication with Juice is slow and data transfer is limited. Furthermore, the raw data needs extensive processing, calibration, and analysis by expert teams before it can be released and properly interpreted. This delay, while understandable, will inevitably lead to predictable speculation and heightened anticipation, making the waiting period almost as intense as the observations themselves. Ultimately, Juice's observations are expected to significantly shift the probabilities. They will push the needle decisively towards either a natural cometary origin, albeit a very peculiar one, or a truly artificial origin. If Juice reveals a fragmented, chaotic mess, the natural explanation gains immense credibility. But if it observes an intact, perhaps strangely regular object, or even detects organized, independently moving probes, then the technological artifact hypothesis will gain unprecedented momentum. The stakes could not be higher. Juice's data might just be the moment we definitively move beyond chai, what if, and step firmly into what is. It could be the clearest picture we get, transforming 3I Atlas from a subject of intense debate into either a remarkable scientific discovery about comet formation or the most profound evidence of intelligence beyond Earth. How ready are we, as a species, for the truth that Juice might unveil, and what will it mean for our understanding of ourselves and our... As the mystery of 3I Atlas deepens, the scientific community, particularly those open to the technological artifact hypothesis, has begun to consider truly audacious proposals. Among the most exciting and controversial is Avi Loeb's suggestion to redirect NASA's Juno spacecraft to intercept 3I Atlas. Juno, a workhorse mission, has been diligently orbiting Jupiter since 2016, providing unprecedented data on the gas giant. But Loeb and his colleagues saw an opportunity for a two birds with one stone scenario, aiming to repurpose a functional spacecraft for a potentially transformative mission. The proposed intercept date was set for March 16, 2026, when 3I Atlas is projected to pass within a relatively close distance of 53.6 million kilometers of Jupiter. While this might sound like a vast distance, for an interstellar object, it's a golden opportunity for a closer look. However, orchestrating such a maneuver isn't like steering a car. It would require a substantial delta V, change in velocity, demanding nearly all of Juno's remaining propellant. This is the kind of commitment that sends mission planners into a cold sweat, sacrificing the extended mission of an already successful probe for a high-risk, high-reward gamble. The optimal window for the necessary thrust application to set Juno on this new course unfortunately passed on September 14, 2025, without NASA approval. This was a significant setback, dampening hopes for the perfect close flyby. However, as with many space missions, later opportunities do still exist, albeit with greater fuel demands and less optimal flyby distances. It means the dream isn't dead, but the challenge becomes even more formidable, requiring even more precision and a greater willingness to exhaust Juno's precious remaining resources. But why go to such lengths? What could Juno, a spacecraft designed for Jupiter, offer in the study of an interstellar object? Its instrument suite, though not purpose-built for cometary or asteroid encounters, could provide invaluable data, near-infrared spectra. This would allow scientists to determine the composition and surface temperature of 3I Atlas with far greater accuracy than Earth-based telescopes. Could it reveal unusual materials or localized hotspots suggesting internal activity? Magnetometer. Designed to map Jupiter's powerful magnetic field, this instrument could detect if 3I Atlas possesses its own intrinsic magnetic field, a rare trait for a natural comet, but potentially indicative of an artificial, powered object. Microwave radiometer. Originally used to probe Jupiter's deep atmosphere, this could potentially provide insights into the subsurface structure of 3I Atlas, looking for density variations or internal components. Gravity science. By precisely tracking Juno's trajectory near 3I Atlas, scientists could use minute gravitational perturbations to measure the object's mass with unprecedented accuracy, offering clues about its density and internal composition. And here's the most tantalizing possibility, one that directly addresses the SETI aspect of the 3I Atlas mystery. Juno AS radio and plasma wave sensor. This instrument could actively search for artificial radio emissions emanating from 3I Atlas. The Juno principal investigator Scott Bolton has confirmed this possibility, adding significant weight to the proposal. Imagine if Juno, our Jupiter explorer, became our first dedicated alien signal detector in situ. It would be an accidental triumph of scientific adaptability. Loeb frames this proposal as a scientific redemption narrative. He passionately argues against the conventional practice of deorbiting functional spacecraft, essentially crashing them into a planet to prevent contamination, when there's a chance at truly transformative science. Why let a perfectly good, highly capable spacecraft burn up when it could potentially solve one of humanity's greatest mysteries? He advocates for using public and congressional pressure to influence NASA's decision-making, urging a bold, risk-taking approach that prioritizes the potential for groundbreaking discovery over conservative mission planning. This isn't just about diverting a probe, it's about a philosophical debate within space exploration itself. Should we always play it safe, or should we embrace calculated risks when the payoff could be monumental? The Juno Intercept proposal represents the frontier of that debate, a daring attempt to seize an unprecedented opportunity. If it were successful, a close-up encounter with 3I Atlas by Juno would not only provide a trove of data, but would also be an inspiring testament to human ingenuity and our unyielding desire to understand the universe. What if, by taking a leap of faith, we could transform a routine mission into one of the most significant space endeavors in history? What profound secrets might Juno whisper back to us from the cold, dark void, if given the chance to draw close to this cosmic enigma? The journey of 3I Atlas has been a gripping saga of scientific intrigue, theoretical daring, and frustrating observational hurdles. But at the heart of the mystery lay a pivotal, unobservable event: its perihelion passage on October 29, 2025. This was the moment of its closest approach to the Sun, a fiery crucible where the fate of 3I Atlas would largely be sealed, yet it unfolded entirely hidden from Earth by the Sun's blinding glare. For approximately 48 critical hours, 3I Atlas was shrouded in secrecy, bathed in the Sun's intense energy. During these critical hours, gigawatts of solar power would have bombarded its surface. For a natural comet, this intense thermal stress is a moment of immense danger. Many comets, especially smaller ones or those with fragile structures, don't survive perihelion intact. They can fragment violently, breaking into numerous pieces due to outgassing pressures, rapid rotation, or thermal stresses. We've seen this happen dramatically with comets like 73P Schwarzmann-Bachmann 3, which broke into dozens of fragments, or Shoemaker-Levy 9, which spectacularly disintegrated before colliding with Jupiter. While 3I Atlas's immense size offers some self-gravitational binding, providing a degree of resilience, it's not immune to the Sun's destructive power. The conventional wisdom for a comet would be to expect some degree of fragmentation, or at least significant outgassing activity. However, if 3I Atlas is, as some speculate, a technological artifact, then perihelion takes on an entirely different strategic meaning. Instead of a moment of vulnerability, it becomes a moment of immense opportunity. A power source, a launch pad, a grand stage for deliberate action. The intense solar energy, rather than destroying it, could be harnessed. Imagine a sophisticated probe using this raw solar power to execute the Earth maneuver. As discussed, this precise braking maneuver to become gravitationally bound to our Sun would require energy and thrust, which could be powered by the Sun itself. Release mini-probes. The dandelion flower hypothesis suggests this would be the ideal time for a mothership to deploy its smaller scouts, using the solar energy for propulsion or activation. Power internal operations. The energy could be used for repairs, data processing, communication, or any other function of an advanced, long-lived probe. Such a maneuver, definitively demonstrating an artificial origin, would be nothing short of the most important news in human history. It would rewrite our textbooks, shatter our preconceptions, and send ripples through every aspect of human society. The immediate economic disruption due to profound uncertainty would be immense. Financial markets would likely experience unprecedented crashes as humanity grapples with the reality of an advanced, silent visitor. The philosophical and existential consequences are almost too vast to comprehend. This brings us to Pascal's wager applied to astrobiology. Even if the probability of 3I Atlas being artificial is low, the enormous consequences of that possibility demand serious attention and resources. The risk of being unprepared for such a profound encounter far outweighs the effort of investigation. It is better to cautiously explore the possibility than to dismiss it out of hand and be caught completely unawares. There's also the intriguing thought of the Trojan horse analogy. What if we are misinterpreting something that appears unusual, but is actually benign? Perhaps it is a natural phenomenon, but one so extraordinary that it stretches our understanding to its limits. Or even if artificial, its intentions could be entirely passive, observational, or even beneficent. We assume nothing and prepare for everything. The truth about 3I Atlas's perihelion passage, however, will not be revealed instantly. It will emerge gradually in November and December, as the object reappears from behind the Sun, becoming visible once again to Earth-based telescopes and, crucially, to ESA's Juice mission. These post-perihelion observations will be our window into its true nature. Did it fragment chaotically, confirming its cometary identity? Did it remain remarkably intact, suggesting an unusual resilience or an engineered structure? Did it release organized objects, providing evidence for the mothership hypothesis? The answers to these questions will provide crucial clues to its true nature, pushing us decisively towards either a familiar, albeit peculiar, comet, or a profoundly strange, potentially technological artifact. The suspense is palpable, the scientific stakes immense. We are on the precipice of potentially redefining our place in the universe, all hinging on what this silent, enigmatic visitor did during its invisible dance with our Sun. The story of 3I Atlas is far from over. In many ways, it's just beginning. The saga of 3I Atlas is more than just an astronomical mystery. It's a profound narrative about curiosity, skepticism, the human impulse to explore, and our often fragile understanding of the universe. As we follow its journey, we can glean several vital lessons that resonate far beyond the realm of astrophysics and apply directly to our daily lives. Embrace the anomalous. Often, our comfort zones are built on established knowledge. But true breakthroughs come when we dare to look at the weird and the unexplained, not as errors, but as opportunities. 3I Atlas forces us to question assumptions. In life, when something doesn't fit the expected pattern, instead of dismissing it, ask why. It could be a glitch, or it could be a signpost to a new understanding. Don't be afraid to challenge conventional wisdom, even your own. The power of data and critical thinking. Amidst tantalizing theories and wild speculation, the story constantly brings us back to data. The need for verified observations, rigorous analysis, and the distinction between fact and fiction, as seen with the amateur signal claims, is paramount. In our daily lives, we are bombarded with information. This story reminds us to cultivate critical thinking skills, to question sources, seek evidence, and not be swayed by compelling narratives without substance. Your own decisions, from personal investments to health choices, are best made with solid data, not just appealing stories. Patience and persistence in the face of uncertainty. The journey of 3I Atlas is marked by long waits for observations, frustrating blackouts, and the slow, methodical process of scientific discovery. There are no instant answers. This mirrors many of life's significant challenges: building a career, nurturing relationships, achieving long-term goals. Patience, persistence, and the ability to tolerate uncertainty are crucial virtues. The biggest rewards often come after the longest waits. Open-mindedness versus uncritical acceptance. Avi Loeb's approach exemplifies a crucial balance: being open-minded to extraordinary possibilities, but always grounding that openness in scientific methodology. This isn't about believing everything. It's about being willing to consider that reality might be stranger than we imagine, without abandoning the need for evidence. In your life, be open to new ideas, new perspectives, and different ways of living, but always evaluate them with a discerning mind. Don't let your mind be so open your brain falls out. The importance of global collaboration and its challenges. The involvement of NASA, ESA, and telescopes across the globe highlights the collaborative nature of grand scientific endeavors. Yet bureaucratic shutdowns and communication lags also show the human challenges. In our interconnected world, collaboration is key to solving complex problems, from climate change to social justice. This story is a reminder of both the immense power of working together and the very real obstacles we face in making that collaboration seamless. Redefining normal. 3I Atlas has consistently defied normal cometary behavior. It forces us to expand our definitions and accept that the universe is probably far more diverse and surprising than our current models suggest. In life, be careful not to box yourself in with rigid definitions of normal. What's normal for one person or culture might be extraordinary for another. Embrace diversity, new experiences, and the idea that your own understanding of what's possible can always expand. The story of 3I Atlas is a mirror, reflecting our fears and hopes about our place in the cosmos. It urges us to look up, to be curious, and to never stop asking the big questions. For what if the most profound discoveries aren't light years away, but right on our celestial doorstep, patiently waiting for us to truly see? What insights has the journey of 3I Atlas sparked in your own mind? Has it changed how you think about our universe, or even your own life? Share your thoughts, and let's continue this conversation. Thank you for joining me on this incredible cosmic journey. I wish you all good health, clarity of thought, and an unending sense of wonder. If you found this exploration as captivating as I did, please consider subscribing to the channel to join our ongoing quest for knowledge and discovery. There are many more stories waiting to be told.